Let's understand multiplication of radicals. You may need to see the video on square root before getting here. Well, from there, let me give you definition of our square root. Square root is one of two equal factors of a number, and square root is the simplest form of a radical. So in our discussion today, whenever I say radicals, it will mean square root. Okay, let's see how to multiply radicals. Let me start with a very simple example. Let's say square root of 9 times square root of 4. As you know, square root of 9 is 3, right? And square root of 4 is 2. And so when we multiply 3 with 2, you get 6. So this is how the result should be. When we multiply radicals, always we may not have a perfect square, and so we may have to do many other manipulations. But this will help us to understand the process. When you multiply radicals, then this could be written as 9 times 4 as 36 within the radical. 9 times 4 is 36. Now, what is 36 equals to? 36 equals to 6 times 6, right? And from our definition of square root, we know square root is one of the two equal factors of a number. So square root of 6 times 6. So we have got two equal factors, 6 and 6. And one of them can be brought out of square root, and we can write this as 6. So we get the same answer. Do you see that? So that's the correct process. So you could do in this process or this way. We may not be very lucky always to get perfect squares. Therefore, this becomes our general method of doing. So in general, let me write, if you multiply radicals, let's say one radical is a and the other is b, then when you multiply, you can write both as a times b within the square root. And then we can simplify this and find the result. So multiplication basically is this. When you multiply two radicals, that's the result. Okay. Now we will do some more examples and hope things will become clear to you as we move on. Let me take very simple examples with you. Square root of 2 times square root of 6. Now square root of 2 times square root of 6 can be written as, will you apply this rule, you can multiply both 2 and 6 and write them in radicals. So first let me just write like this, simple steps, and then 2 times 6 is 12. So we can do square root of 12. Now 12 can be written in factor form, and we know we have a perfect square as a factor of 12, and that is 4. So we can write this as 4 times 3. Now since 4 is a perfect square, it is 2 square, right? Times 3. So this could be written as 2 square root 3. We can bring this out. Therefore, I can write 2 times square root 6 as 2 square root 3. We'll do this process once again to see how we'll just build, and slowly and gradually I think you will start appreciating the process. Let's say now this time multiply square root 3 times the number 15. Okay, so when you multiply with our rule, we could write this as square root of 3 times 15. And now I can factor 15, and I can write this as 3 times 15 is 3 times 5. 3 times 5. And so we get two numbers which are equal. Two equal factors within a square root is square root of the number. So this is 9, and 9 is 3 square. So 3 can be brought out. So this could be written as 3 square root of 5. So when we multiply these two radicals, we get 3 square root 5 as our answer. Do you get the concept? Let's try some more questions, okay? Some more. It is just a simple concept, and I think with few problems, if you practice, you can get multiplication, right? Now, one more example. Now here what I will do is, I will take lesson number 6, right? I'm selecting numbers very carefully for you. See, 6 has two factors. And how have I selected the numbers? 6 has two factors, 2 and 3, right? And so I'm selecting another number which has at least one of them as a factor so that I can show you the process of how the things are being done. And this time I'm taking a very interesting number, and that is 27. Now 27 can be written as 9 times 3 or can be written as 3 times 3 times 3. So I'm just showing you thought process as we move forward. So I can write this as square root of 6 times 27, and we know they are factors. So let me now write these factors. Instead of 6, I will write 2 times 3, and instead of 27, I will write 3 times 3, 9, 9 times 3, 27. So I'll write 3 times 3 times 3, correct? Now how many equal pairs do we have? Each one can be brought out, you see. So 2 doesn't have a partner, right? So 2 remains there. So this is equals to, let's put 2 first here, and we can bring out 1 3 from these two and 1 3 from here. So we get 3 times 3 out. Do you see that? Which is 9. So this is equal to 9 square root of 2. So you can make your own problems like this and see, it's very interesting, and see how we can build on this, correct? Now we will do a bit more of multiplication, and I'll give you some questions so that you can practice, correct? You got the idea. So the questions which you can practice here are like this. So we'll take square root of 8, and I know the factors of 8 will include 2, 2, 2. There are 2's in 8, right? So I should take a number here which is also even, and I know a couple of 2's can be factored out. 4 is also a factor here. Let me take a number 20, correct? 20 has 4 and 5 as a factor. You can find when you multiply this, what do you get? B. We can have a number like 15. 15 has 3 and 5 as a factor. So you can multiply this and you can have a number 21. Correct? You can try this out. What do you get? One more problem I'll put here as number 36 times, let's say, number 9. Well, 9 is itself has perfect square, right? So we can bring it out. So try these questions and understand what is happening in multiplication, and then once you multiply, we are doing the process of simplification. So we are doing both the process of multiplication and simplification. Now I will introduce you to another term, and that is mixed radical. Okay, so this time what we will do is we'll kind of go reverse, right? All these are called mixed radicals. They have a number and a radical, a number and a radical. Do you see? A number and a radical, correct? So these are all mixed radicals, mixing radicals with the number. Simple as that. Now let me take a radical, let's say, and we'll try to simplify the radical. So let me take, let's say, square root of number 32. Number 32 can be written as 2 times 16. And 2 times 16, 16 is a perfect square of 4. So 4 square, right? So like 2 times 4 square, square root. And now this can be brought out, and so it becomes 4 square root 2. So when we do this, we call this as a mixed radical, because this is the radical part and that's the number before the radical. So that's a mixed radical. Do you get the concept of mixed radical? Correct. So when we multiply, we might get a radical. So we will write another example here. We will do like, you can say square root of, let's say, number 20 times square root of 10. Now here it becomes square root of 20 times 10, correct? So we have 20 and 10, right? So we can write 20 as 2 times 10, correct? Times 10. Now 10 is 2 equal factors, so square root will be 10. So we can bring out 10 outside and get 2. So this is answer written in simplified form by some mixed radical. This what is a mixed radical. Okay. Now the question for you is, if area of a square equals to, let's say, 72, find length of its sides. Okay, so length will be what? Square root of 72. So basically you have to find square root of 72, right? So if you are given area of a square, then side length will be square root of that number, right? So we learned a part of multiplication of radicals today and kind of reviewed what we learned in the previous video on square root, correct? I hope that makes things clear to you, and now we will see other operations, arithmetic operations on radicals in the coming videos. Okay, thank you.